Okay, in today's session, we are going to be talking about binary numbers. Before we go into what are binary numbers, let us look at the current system that we have. How do we use numbers for counting currently? So we use what is called as the decimal system. For example, let us say you're counting from 1 to 25. You start with 1, 2, 3, 4, 5, 6, 7, 8, 9. And then when you come here, you put a 10. There is no number that goes beyond 9 or goes beyond 10, let us say. So what you do after this, you keep this 10 aside, which you've already counted, and start with the numbers all over again. And just bear with me and I'll show you what happens. So you already counted 10. You kept 10 separately. So now because these are the numbers that you're counting after 10, you just put a 1 before them to show that these numbers are 10 plus each of these numbers. And then now that you've come to 19, so you want to tell the count or tell people that, okay, I've counted 19, which is 10 plus 9, and then I want to add the two tens, and I'm going to call this 20. So now you have counted till 20. You counted 10, and then you counted another 10. So I want to count to 25. So what do I do after that? I keep the 20 aside. I've already counted 20. I just add 1, 2, 3, 4, 5. So I stop here. Because I've already counted 20, I want people to know that this is 20 plus each of these numbers. So I put a 2, 2, 2, 2, 2 here. So this is how we count numbers right now. What it means is that we call it the decimal system or the base 10 system. Base 10 system means the system uses a 10 base. So let's talk about what is a 10 base. So I'm just going to draw, well, this is not my hand, somebody's hand. Just assume that this is a hand. So let us say you're counting with your hands. Start with 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. After 10, you cannot count 11 in the same hand. So what you do, you keep this 10 separately and again start 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So you counted 10 two times. And if you want to count 25, you count another 5 and put it here. And you add all this together, you will get 25. So basically, what this means is the system of counting that we use is based on the number 10. And that is why it is called the decimal system. DEC means 10. That is why December means 10th month. And I know why you're saying December, why I'm saying December is the 10th month, because December is the 12th month. That's a little bit of history. We can talk about it later. December used to be the 10th month at one point before July and August were added. So decimal means 10, and base 10 is a system that we currently use in our normal calculations, in our normal okay. So let us look at something else in the decimal system. In the decimal system, there is something called place value. Place value. What does this mean? So let me write a number 9,612. So depending upon where the digit is located, the value of the digit will change. That is what is meant by place value. So this is what we call as the ones digit or ones place. This is the tens place. This is the hundreds place. And the last one is the thousands place. I'm sure you must already be aware of this. Depending upon the position of a number, the value of that digit will be different. So this place value system is there in the decimal system. But if you take Roman numbers, for example, Roman numbers 6 is written as V and I. And then 16 is written as X, V, and I. So here the order matters, but the position does not matter. So you can write 8 like 18 like this. So just because an I is here, it may not have a different value. Unlike the decimal system or even the binary system. We will talk about the binary system a little later. First, let us finish off the decimal system. Okay, so what this means is each of the places. So this is, I can write this as 2 into 1, right? And I can write this as 1 into 10. And this is nothing but 6 into 100. And this is 9 into 1000. So if I multiply all of this, I get 9,610 and 2. If I add all of these together, I will get the number 9,612. So basically, this is what is meant by when I say the place value of the number determines the value of that number, depending upon which position the number is. So there is something called scientific notation where we use the powers of 10 to tell the size of the number. For example, if you take 9,000, let's start with 9,000. 9,000, I can write it as 10 to the power of 3, because 10 to the power of 3, as you already know, is 1,000. Basically, 10 into 10 into 10 is 1,000. So 9 into 10 to the power of 3 means 9 into 1,000, 9,000. 6, I can write it as 6 into 10 to the power of 2. 10 to the power of 2 is 100, 10 into 10. So 600 is 6 into 10 to the power of 2, and 10 is 1 into 10 to the power of 1. And 2, I can write it as 2 into 10 to the power of 0. So why do I write 10 to the power of 0? Because 10 to the power of 0 means 1. Any number to the power of 0 is 1. Any number, if you take any number, if it has a power of 0, that means it is 1. Any positive number. So this number 9,612, I can write it as 9 into 10 cube plus 6 into 10 square plus 1 into 10 or 10 to the power of 1 plus 2 into 10 to the power of 0. This is one way of splitting up any number into powers of 10. And if you look at it closely, here 9,000 is 9 into 10 to the power of 3. Here you have 6 into 10 to the power of 2, 10 to the power of 1, 10 to the power of 0. So even if you split the number, all of the digits, the values of all the digits is based upon the number 10. And that is why we call this the decimal system of counting. So let's just go back and quickly revise what we studied. We use the decimal system currently, which is also called as the base 10 system, because number 10 is the base for all counting in the decimal system. We talked about how if you want to write 25, you go from 1 to 10, and then you start all over again, go from 1 to 10, and then you add the 1 in the front to show that you already counted 10, and you're counting the rest of the numbers, the rest of the digits. And similarly, when you have counted 20, you keep 20 separately and then count another 5. You add 2 to the beginning just to show that, okay, you already have 10 in the pocket and you're counting another 5. This is how you count in the decimal system. And then we talked about the place value. The place value determines the value of that particular digit. So this is the ones, tens, hundreds, and thousands place. And if 9 here is in the thousands place, it is nothing but 9 into 1000, 6 into 100, 1 into 10, and 2 into 1. That is how the place value works. So if you look at this, all of this is based upon the number 10. And this is the system that we use for counting now for normal purposes, and it is called the decimal system. So this is an introduction to show you how the decimal system works. When we go to the binary system, some of the concepts that we reviewed in the decimal system will be very helpful. Okay, I hope this was clear. So we will next look at what is called the binary system of numbers or binary numbers. Okay, so let us look at the binary system of numbers. We just looked at the decimal system, and we will use some of the learnings from the decimal system to understand how the binary system works. So let us say you have only 2 fingers in your hand, and you want to count the number 11 using the 2 fingers that you have. So you start from 0, actually you start from 1, and you go to 2. And for 3, you go back here again. For 4, you go back here. For 5, you come back here. 6, you come back here. So you can count up till only 2 with the 2 numbers. Let us take this, how we write this number 11 in the decimal system. So we go over all the way to 10, and then we write the number 11 here. But let us, if you want to do the same thing in the binary system, the only digits that are available to you are 0 and 1. So let's start with 1. 1 will be 1. So this is the decimal system, and this is the binary system. 1 will be 1 in the binary system. It will be the same. 2. There is no number 2 for in the binary system. So what we do is we write it as 1, 0, just like we write 10 as 1, 0 in the decimal system. Because it is base 2 instead of base 10, 2 is written similar to how 10 is written in the decimal system. So after 1, we get 1, 0, and 1, 0 is nothing but 2. So how do you write the number 3? Number 3 is, we already have 2 written as 1, 0, and then we have one more. So just like we write number 13 as 10 plus 3 in the decimal system, you write number 3 as 2 plus 1. So you will get 1, 1. 1, 1 in the binary system means 3, which is 1, 0 is 2 plus 1, which is 3. 1, 1 in the decimal system, of course, is 11, which is a different number altogether. Okay. So in the binary system, we have only 2 digits that we use. For 1, we use 1. For 2, we cannot use 2. So instead, we write 1, 0, which is similar to what we write as 10. And 3, we write 1, 1. And for 4, what do we do? 4 is just like 100 in the decimal system. So we write 4. So we write 4 as 1, 0, 0. But let me try to show you how we get 1, 0, 0 from 3 again. So 1 is 1, 2 is 1, 0, 3 is 1, 1. So 4 is nothing but 3 plus 1, right? 3 is 1, 1, and 1 is 1. How do you add 1, 1, 1, and 1 in the decimal system? So you put one over the other. Add 1 plus 1 is 2. 2 is nothing but 10, or 1, 0. So you put 0 here and you carry over the 1. And then 1 plus 1 is 2. 2 is again 1, 0. So you put the 0 and write it here. So you get 1, 0, 0. So 1, 0, 0 is 4 in the binary system. So how about 5? 5 is nothing but 4 plus 1, which is 1, 0, 0 plus 1, which is 1, 0, 1. So 5 is 1, 0, 1. How about 6? 6 is 5 plus 1, 1, 0, 1 plus 1. 1 plus 1 is 2. 2 is nothing but 1, 0. So you put a 1 here and you put a 1 here. 1 plus 0 is 1 and you bring the 1 here. So 6 is written as 1, 1, 0. 7 is written as 1, 1, 1. How do you write 8? 8 is 1, 1, 1 plus 1. 1 plus 1, 2, which is 1, 0. And then 1 plus 1, 2, which is 1, 0 again. And you take the 1 here. 1 plus 1, 2, which is 1, 0 again. We write 8 as 1, 0, 0. And 9 is nothing but 1, 0, 0, 1. And 10 is, let's do it here. 10 is 1, 0, 0, 1, which is 9 plus 1. 1 plus 1, 2, which is 1, 0. And then 1 plus 0 is 1. 0 is 0. And 1 is 1. 1, 0, 1, 0. So this is how you write numbers 1 to 10 in the decimal system. So let me go through this once again so that you're very clear on this. So in the case of the binary system, you have only 2 digits. You have only 2 digits. You have to use the digit 0 or you have to use the digit 1. And binary system is what we call base 2. Just like the decimal system is base 10, binary system is base 2. So let us try to write the numbers 1 to 10 in the binary system. You start with 1, 1 is the same. You go to 2, there is no number 2. And so we write 2 in the same way, right? We write 10. So you have 1, 0 as 2. Let's see how do you do that. 1 and 1, which is 2. 1 plus 1 is 2, but there is no 2, so you put a 0 and then a 1 in front of it. And 3 is nothing but 1, 0 plus 1. You get 1, 1. And then 4 is 1, 1 plus 1. 1, 1 plus 1, if you add, you do it like this. 1 plus 1 is 2, which is 1, 0. And then you put a 1 on top, 2 again, which is 1, 0. And similarly, if you keep on adding, using the two numbers 0 and 1, you can depict the numbers 1 to 10 in the binary system. So if you're still confused, just try to watch the last 10 minutes again. And anyway, when we do more exercises, I think you will understand. This will be much clearer. Okay, so binary versus decimal. If you remember, when we were looking at decimal numbers, we looked at something called place value. For example, if you take the number 789, 7 is nothing but 700. The place value of 7 is 700. The place value of 8 is 80. And the place value of 9 is 9. So this can also be written as 7 into 10 to the power of 2. This can be written as 8 into 10 to the power of 1. And this can be written as 9 into 10 to the power of 0. So when we looked at the decimal numbers, we saw how we could split the numbers based on the place value. So let us take a binary number 11011, let us say. So this is nothing but 2 to the power of 0. Just like this is 10 to the power of 0, 10 to the power of 1, and 10 to the power of 2. This is 2 to the power of 0. This is 2 to the power of 1. And this is 2 to the power of 2. 2 to the power of 3, and 2 to the power of 4. So if I want to write this number 11011, if I want to write this binary number in decimal form, what do? I just take 1 into 2 to the power of 0 and take 1 into 2 to the power of 1. So I can just do this like 1 into 2 to the power of 4 plus 1 into 2 to the power of 3 plus 0 into 2 to the power of 2 plus 1 into 2 to the power of 1 plus 1 into 2 to the power of 0. So 2 to the power of 4 is how much? 16. 2 to the power of 3 is 8. 0 is 0, so just leave it like that. 2 to the power of 1 is 2. 1 into 2 is 2. And 2 to the power of 0 is 1. So 1 into 1 is 1. So this is 16, this is 8, this is 2, and this is 1. You add that 24 plus 2, 26 plus 1, 27. So the number 27 can be written in binary format as 11011. 11011. So this is one way to convert a binary number into a decimal number. But before that, let us look at how to convert a decimal number into a binary number. But you must understand this concept of what is similar to place value in the decimal world. So the first digit from the right side, this is 2 to the power of 0, this is 2 to the power of 1, 2 to the power of 2, 2 to the power of 3, and 2 to the power of 4. Just like we have the same in the place value for the decimal 0, 1, 2, 3, 4, and so on and so forth. So we had an example where we took a number and converted it to decimal value. Before we go deeper on that, let's look at how to convert a decimal number to binary number. Decimal to binary conversion. So let us take the decimal number 8 and I want to convert it to binary. So what I'm going to do is that I'm going to repeatedly divide 8 by the number 2. So 8 divided by 2 is 4. I just let me cancel this. I write 4 here. 8 divided by 2 is 4. Remainder is 0. Again, I divide 4 by 2. Again, I get 2. Again, the remainder is 0. Again, I divide by 2. I get 1, and the remainder is 0. So now what I need to do, I need to take whatever is the remainder here and all these remainders and put them one behind the other. And this is my number in binary form. So this is basically the value of 8 in binary form. How did I convert 8 to binary? I kept on repeatedly dividing it by 2, and I noted down the remainders until we get to a place where the remainder is less than 2. And then you take all the remainders, put them together, you will get the value of the number 8 in binary form. Let us take 1 or 2 more examples, and let me show you how that works. Let us take a number, odd number 11. I divide by 2. So what do I get? I get 5, but I get a remainder of 1, right? So I divide by 2 again. I get 2 and a remainder of 1. And I divide by 2 again. I get 1 and a remainder of 0. So I'm going to take all these numbers and put them one behind the other. So 1, 0, 1, 1. So this number in binary equals 11 in decimal. So the way we denote decimal and binary so that we are not confused. We just put curly braces or curly brackets and put the number 2 or 10 around that number to show if the number is binary or if the number is decimal. So how do I know if 11 is actually 1011? Let me try to convert it back to binary. So 1 is 1. In this place, this is, okay, so this is 2 to the power of 0, this is 2 to the power of 1, 2 to the power of 2, and 2 to the power of 3. So let's take 1 into 2 to the power of 3 plus 0. I can ignore the 0. I take 1 into 2 to the power of 1 and 1 into 2 to the power of 0. What do I get? This is 8 plus this is 2, and 2 to the power of 0 is 1. 1 into 1 is 1, and this is 11. So when we converted 11 into binary, we got 1011. When we converted it back, we got 11. So this is the way we got the correct answer. So this is the way we convert a binary number. Convert a decimal number into a binary number. Let us take a big example and see how that works. Let's take the number 444 or 443. So what we are going to be doing, we are going to be repeatedly dividing it by 2. Repeatedly dividing it by 2 till we get either 0 or 1 as the remainder. Okay. So divide 443 by 2, I get what? 2, 2, 1, and I get a remainder of 1. Because 3 by 2 is 1, and the remainder is 1. So 221, again I divide by 2, I get 1, 1, and 1 divided by 2 is 0 with a remainder of 1. Okay, let us keep going. I have 110. I'm going to divide it by 2 again. So this becomes 55. And there is the remainder of 0 because 55 evenly divides 110. So divide 55 by 2, I get 27 and a remainder of 1. I can divide 27 by 2, I get 13 and a remainder of 1. Divide by 2 again, I get 6 and a remainder of 1. Divide by 2 again, I get 3 with a remainder of 0. And divide 3 by 2 again, 2 ones are 2, and I get a remainder of 1. So I put all of them together. 1, 1, 0, 1, 1, 1, 0, 1, 1. So 1, 1, 0, 1, 1, 1, 0, 1, 1, 1, 0, 1, 1. And this is equal to the number 443. So let us try to check if we did the conversion right. So this is 2 to the power of 0, 2 to the power of 1, 2 to the power of 2, 3, 4, 5, 6, 7, 8. So I get 1 into 2 to the power of 8 plus 1 into 2 to the power of 7 plus 0, we can ignore it, and then 1 into 2 to the power of 5 plus 1 into 2 to the power of 4 plus 1 into 2 to the power of 3 plus 0 we can ignore, and then 1 into 2 to the power of 1 plus 1 into 2 to the power of 0. So 2 to the power of 8 is what? 2 to the power of 16, 16, 6 are 256. Let me see, 2 to the power of 4 is 32, 5 is 32, 6 is 64, 7 is 128, 8 is 256. And this is 128, and this is 32, and 16, and we have 8, plus 1 into 2 is 2, plus 1 into 1 is 1. To add all of this together, 256, 128, 32, 16, 8 to 1. 3 plus 8, 11 plus 6, 17, 19 plus 8, 27, 33. And then you have 8 plus 2, 10, 13, and 14. and then 1, you get 4. So you get 443, which is the number that we were trying to convert to binary. So this is how you convert a number from decimal to binary. You keep on repeatedly multiplying, dividing by 2, and you take all the remainders and put them together, and you will get the number in binary format. Okay. So you can continue, you can practice this with other numbers, and you can convert them back to decimal. You should be able to get the same number again if you did it right. And it is pretty simple. All you have to do is divide by 3. Divide by 2 till you get a remainder of 1 or 0.